Hey there, students. In this clip, we're going to go over how to graph polar coordinates as indicated in the learning objective. So let's write down the title of this lesson. This is the Calculus Unit for Lesson 1, graphing polar coordinates. Graphing polar coordinates. Now you've learned how to graph. You learn how to graph rectangular coordinates very earlier on, maybe in middle school or even elementary school. So now we're expanding on your graphing repertoire. It's not only going to be restricted to a rectangular plane. Now you're going to extend it into circular coordinate systems, which has its own special application. So let's first of all define what the two distinct rectangular coordinate systems that we know are. So the first one is a rectangular coordinate system. So a rectangular coordinate system, the one you're used to, a rectangular coordinate system given by xy is a position of an object from two fixed points. Okay, from two fixed points. Okay, that's how you graph the coordinate system. It's a rectangular coordinate system. You indicate the position of an object using two fixed points. So what does that look like? Let's make a sketch as to what a rectangular coordinate system looks like. All you need is an x component that has to be fixed and a y component that has to be fixed, right? Because this is your y coordinate and this is your x coordinate. And at the intersection of these two, there goes your coordinate. So this one traces out to that, and this one traces up to that, and there goes x, y. So this is your standard rectangular coordinate system. Now what does a polar coordinate system look like? Well, let's define that polar coordinate system next. Write this down. A polar coordinate system instead of xy is going to be r theta. R is for radius, theta is for angle. Okay, r is radius, theta is angle. So a polar coordinate system r theta is a position of an object, just like before. Position of an object, just like this one, of an object using a point known as a radius and an angle. You can refer to it as theta. Okay, so we're going to use a radius, a point, which is the radius, and then an angle, which is theta. Okay, so what does that look like? Well, it just involves going out on a point and then rotating to create the angle. Okay, so what does that look like? First thing you always have to do is you first have to graph the radius. Okay, so let's say the radius were r units long. So let's say it's r units long, so you're going to go, this is going to be r. Okay, so how far you go out, always to the right, is your radius. Okay, so this is r right here, and then from here you're going to rotate. You're going to rotate at a certain angle. So when you rotate, remember the length doesn't change, right? You're just going to rotate a little bit. Let's rotate, we're going to call this at an angular measure of theta. Alright, so this is just a rough sketch. So we're going to rotate theta. So if this one rotates up theta, is going to take us up to a point right here. So this point right here is a combination of r, which is how far you go out to the right, and theta, which is how far you rotate. Okay? So this coordinate right here is r, comma, theta. So that's how you have your coordinate, your polar coordinate system. You go out and then you rotate. Okay, out and rotate. So that's that. Alright, let's take a look at some examples to solidify our understanding about how this system is graphed. Alright, so example 1, or I can just write examples, and then what we're going to do is we're going to graph each point. Graph each point. Okay? Graph each point. So the first one we're going to graph is the point 2, 45. 2, 45 degrees. Okay? So you should have your coordinate grid with you on the worksheet, on the grid I handed out, so that you can place a graph on here. So let's go ahead and use it to graph it. So we're going to graph the radius and then the angle. So don't forget, the first one is always r, and this is theta. Okay, r is how far you go to the right, theta is how far you rotate. So we're going to go 2 units to the right and rotate 45 degrees. Okay, so starting from 0, 0, the solid ones are units, and then the lighter ones are fractions. So this is 1/2, 1, 1 1/2, 2, 2 1/2, 3. Okay, so we're going to have 2. So you're going to go from here, 1, 2, that's the radius. But we don't just need the radius, we also need the angle. So we're going to rotate 45 degrees. So 45 degrees should be right here. Okay, so you rotate, you go out 1, 2, and then rotate 45 degrees. And there goes your point. Always put a label, the letter, on your final point. So let's say this were A. Just call this is point A. And there goes your final answer. Alright? Alright, now we're going to take a look at another. Okay, let's try another example. Number 2. We're going to graph the point. Point B is the B this time. Negative 345. Okay? Negative 345 degrees. Remember, this is the radius, and this is the angle, theta. Alright? So we're going to attempt to graph this point. So what I'm going to do here is I'm going to draw the positive one first and then do the reflection afterwards. Okay? So I'm going to start by graphing 345, and then I'm going to apply this reflection. Alright? So this is R, and this is theta. Now where is 345? That's going to be difficult. 345 should be somewhere here. So we go 1, go with the thick ones, 2, 3, and then rotate 45 degrees down, right there. Okay? Because that's 45. Going up 3, rotate 45. That gives you this point. Now what on earth does a negative radius mean? A negative radius means you're going to reflect along the radius, across or up, down, or side to side. You're going to reflect across the radius. That's what a negative radius means. Either up, down, across, or side to side. That's what a negative radius means. What does a negative angle mean? Negative angle is much easier. Negative angle simply means you reflect up and down. That's it. Okay? Alright, so in this problem, only the radius is negated. Alright, so what is that going to look like? It means that on this point has a radius. This is the radius that this point is on. So all you simply do is reflect this to the other side. You don't want to go out of the circle, right? So since this goes 3 units up, 1, 2, 3, you're gonna go stay on this radius. You're gonna do what? Reflect 3 units down. So that's gonna look like this. 1, 2, 3. Bam. Your answer B. That's negative. Negative radius means just stay on the radius, wherever the radius is, and just reflect on that line, that radial line. You just reflect on it. Okay. So there goes the answer. Alright, let's try another example. Example 3. Right now we're going to graph point C, which is 4, comma, negative 5 pi over 3. Okay? Now remember, this is the radius and that's the angle. I would like to start by first graphing the positive 1, and then I'll apply the reflection using the reflection rules, okay? So the positive 1 I'll graph first is I want to start with 4, comma, 5 pi over 3. Let's forget about reflecting for now, okay? So this is R and this is theta. What is that going to look like? We're going to go starting from here. 1, 2, 3, 4. 5 pi over 3, where are you? Oh, down there, so down. Oops. So basically 5 pi over 3, 1, 2, 3, 4. So it's as though you started here 4, and then you rotated along that radius. Bam. To 5 pi over 3, 4. Okay? That's not what I want. I need 4 and negative 5 pi over 3. So when you negate remember when you negate the radius, it means you reflect any direction along the radius, right? Across, up, down, whatever. If you have a negative angle, it's simply up or down. Nothing else. If you're up, you go down. If you're down, you go up. So theta negation is up or down. Okay? So, let's see. We're down here, so we can't go lower because we're already down. Since the theta is negative, we're just going to reflect straight up. Okay? If you can't visualize it, you can use a pen or a pencil to just make sure that your reflection is perfectly straight. This is the last line here, so your reflection should go. Let's see. Let me do it again. Your reflection should go straight up to that point right there. That's the point we need. Okay? To be a straight reflection up there. So our answer, if I reflect straight up on this format line, is going to take me right here. See that straight reflection right there? Bam. That's the answer I need. Alright, so that is C. That's the final result. Okay. Now let's try one more example and then we can start some classwork problems. Let's try number 4. How about we try D point -2 and -210 degrees. Uh-oh, we have a problem with both of them are negatives. So we're going to be doing 2 reflections here. So this should be an interesting one. Let's see how that looks. Remember, this is R and this is theta. What I like to do is I like to start from the original, and then I'm going to do one reflection at a time so I don't get lost, okay? So let's start with 2 and 210. Where on earth is that? Where's 2 and 210? Let's see. 2 and 210 means you go out 2, and then you rotate all the way to 210. Right there. Yeah. That's 2 and 210. So which one do you want to do first? The radial reflection or the angular reflection? It doesn't really make any difference to what you do. You will end up in the same place. So let's do the radial reflection first. So if I do the radial reflection, which is -2, 210, this means I'm going to reflect along the radius. Okay, either across or up and down. So this is the radial line right here. Since I'm here to the bottom left, I need to go upper right, straight up. On this line, you see on this line right here, I need to go to So I go 2 down, I'm going to go straight on that line, 2 up, and it's going to take me right there, down. See that line right there? You gotta stay on that line. Okay, when you're reflecting it, so you don't mess up the whole thing. Stay on that line and just reflect straight up like that. Okay. So that's the first step. We just did our radial reflection. Okay. So started here, and then we ended up there. Okay. Now the next thing we're going to do from here is we're going to apply our angular reflection, which is negating theta. So what we're going to do is we're going to apply this rule, and we're going to go negative 210. So if I negate an angle, what effect does it have? It's simply up or down. Nothing more. Okay, up or down. If you're up, you go down. If you're down, you go up. So we're up here, so what does that mean? It means we're going to go straight down. Boom, like that. Straight down. So this is the first line. We're going to go the first line going down. So if we go straight down, that is exactly what I want. Okay? That is exactly what I want. So that is point D. Okay? Do you notice a trick with this? Anytime you have both negatives, it's simply equivalent. If you're both negative, it's simply equivalent to a side-to-side reflection. Okay? So if you have a point on the right, if they're both negatives, it takes you to the left. If you have a point on the left, if they're both negative, it takes you straight to the right. Okay? So a combination of a radial and angular reflection is a horizontal reflection. So that's a shortcut. So I went up and down. I could have just gone sideways. It's the same thing. Alright? So we're going to go ahead and start on the classwork problems. Alright, welcome back, students. Now we're going to go on to the second part of the notes, where we're going to be making some more, we're going to be extending the ideas that we covered some of the ideas we covered in the initial part of the classwork, in the first part of the notes, okay? So we're going to be doing some extreme reflection and rotations here. So, so write down this example in your notes. This will be graphed on the graph paper. So in your notes, write down name, 5 other pairs for the given polar coordinate. So name 5 other pairs for the given polar coordinate. Number 1, what if we had the point R, which is 1.5, comma 210. Okay. So before we start, let's graph the points where it lies. Okay. So for this one, actually, I would like you to give me two rotational pairs, 2 rotations, and 3 reflections. Okay. That gives you 5 in all. 2 as a consequence of rotation, and the other 3 as a consequence of some kind of reflection. Okay. All right. So let's graph the point. 1.5 and 210. 1.5, 1.5 in the center here. 210 means you're gonna rotate all the way here. So I think there should be a point R. All right. So that's 1.5 and 210. So 2 points that rotates to give you, they'll take you right here. So if I can rotate up or rotate down, okay? If I rotate up full circle, I just need to subtract 360, right? If I rotate down full circle, I just need to add 360. So if I add 360 and subtract 360 from this angle, that gives me like 2 points per rotation. Okay? So to get the first one, I'm going to do 210 plus 360 degrees. Focus just on the angle because you're rotating, okay? Theta means rotation. So if I add 210, that means I'm going to go down here and go woo, all the way around back here, okay? So 210 plus 360 gives you 570 degrees. Alright? So our first, it's good for us to organize our work so we don't get confused. So for rotation, my first one is going to be 1.5, comma, what I get when I add 360 to 210, which is 570. So there goes my first answer. This is a counterclockwise. Remember, counterclockwise is positive, right? Counterclockwise is positive, and clockwise is negative. So what if I go the other direction, full circle, like this, woo, over here? How does that apply to the angle? That just simply means I'm going to take 210, and I'm going to subtract 360 from 210. Okay? So what is 360? I mean, what is 210 minus 360? Let's do that real quick. What happened to my calculator? So 210 minus 360 gives me negative 150 degrees. So negative 150 degrees. These are called coterminal angles. This is a positive coterminal angle. This is a negative coterminal angle that we talked about earlier in this course. So our second rotational point that's exactly the same as this is going to be 1.5, comma, negative 150. Okay? Alright. Now, how about reflection? How about reflection? We already have two rotations. Now we need three reflection points. So how's that gonna look like? So I just need three targets that I can reflect to give me the points that I need. Okay? So let's see. I'm gonna write reflection. Let me put the reflection here so I don't have to make this reflection. I need three. Alright, so this is how you do it. You look at the circle that this point is on, point R. See the circle right here? See the circle? So all the points that can reflect to hit this point will be the points that I need, okay? So if I reflected this one straight up, it's going to take me here. Okay, let me get that in, right? If I reflected straight up, it's going to take me here. If I reflected to the side, it's going to take me here. And if I reflect it along the radius, it's going to take me right there. Okay? It's kind of like a rectangle. Like you draw a rectangle using that. Okay, and then we're going to use our reflection rules to create the answer that we desire. Okay? So we're going to look at what these three coordinates are, and then we're going to ask ourselves, what can I do to this to take it here? What can I do to this to take it here? And then what can I do to this to take it there? Okay? That's what the question is. Okay. So the first, let's write out what these points are. So for this point right here is 1.5 and 150. Okay? So 1.5 and 150 is my first candidate. 1.5, comma 150 is the first one. Now, if I want to get from here to my target, which is 1.5 and 210, I need to reflect downwards. So what's the downward reflection? Downward reflection, if you have R and theta, if you do the negative of the angle, you go up and down. And then this one goes across. Okay? So if I go down, guess what? Only the angle goes negative. So your first reflection is going to be 1.5, comma, negative 150. Because by simply negating the angle on this, it takes you right here. Boom. Okay? So that takes care of the first point. Now, let's pick the next point. This one right here is 1.5, and 30. 1.5 and 30. So this one I need to go across. Is it a reflection along the radius? So what do I negate to accomplish a radial reflection? Simply negate the radius, right? If I simply negate this radius, guess what? It's going to take me from here, boom, all the way here. So the next name for this point, the same as this, is simply going to be negative 1.5, negate just the radius and keep the angle the same, 30 degrees. That's the third one. The fourth one. Now this point here, this is a weird one. What's the coordinates first? The coordinates at this point is 1.5, 1.5, and 330. So 1.5 and 330. Now this one is sideways. Okay? I never told you anything about sideways here. This one's either along the radius or this one's along the angle. So if you have a sideways reflection, you want to go from here to here. All you simply do is a combination of up and down reflection and a radial reflection. So if you go up, you negate the radius. You go across, you negate the angle. So if you negate these two, that'll take you up and over or across and down. Alright? So if I do, if I negate 1.5, negate 1.5, that's going to take me from here over here. And then when I negate the angle, negative 330, guess what? That takes me straight down. So if I take the opposite of these two, that gives you a vertical, a side-to-side reflection. So don't forget, anytime they're both negatives, you end up with a side reflection. Okay? So your points, all the points together are all this. So this. We can put the other ones down here. So we have, let's see. Oh, we have an overlap. So negative 1.5, 30 degrees, and then negative 1.5, negative 330. We need one more because this one is already taken. So all you do here is just add either subtract another 360 or add another 360 to the original one. So this one I can just subtract another 360, that'll take me right back to the point. So it's going to be 1.5. If I subtract 360 from this, it's going to be negative 510, I believe. The reason I did this is because we have the same answer twice. So just anytime you have an overlap, just rotate again. I can either add 360 or subtract 360 from any of these two to get my answer. Alright? So here goes all your 5 answers. Alright, I'm going to give you an example to try out, and then we'll go on after that. Okay, now I'm going to have you guys try this one out, okay? Example 2. What if we had point K, which is negative 2, comma pi over 3. In this one, just know that we're using radians here, so you go with 2 pi as opposed to 360, okay? So let's try this one out and see what it looks like, okay? Alright.